Okay, this question here, we're given a function and we're asked to show that the function simplifies as follows. Okay, now we've seen ones like this before. All we're really supposed to do is we're going to combine these terms. We're supposed to factorize first, and then we're supposed to make sure the denominators have the same factors in them. So let's go ahead and do that. So the first thing I'm going to do is I'm going to state that for part A, f of x is equal to the following. So I've got a 1 here. I'm going to add, I'm going to give plenty of space here, 4x currently over 2x, take away 5. And then I'm taking away 15 divided by this here, which I'm going to straight away factorize. So that's going to factorize as follows. Make sure you take your time to factorize. So it's going to be equal to negative 5 and negative 1. If you want to be absolute 100% in the exam, what you can do is just to check at these stages to make sure you're not making little mistakes under pressure. What you can do is you can go to mode equation, which is 5, and solve a quadratic. And if you solve this quadratic equals 0, so a is 2, b is negative 7, and c is 5, it gives you the answers 5 over 2 and 1. So you know that x equals 5 over 2 and x equals 1 are the solutions. So doubling both sides here, 2x equals 5 and 2x take away 5 equals 0. That must be a factor, and similarly x subtract 1 equals 0 must be another factor, and hence you get your factors. Okay, anyway, to make these have the same denominator, this must be multiplied on top and bottom by x subtract 1, and this must be multiplied on top and bottom by both factors. So it's going to have on the denominator the 2x subtract 5, x subtract 1, and on the top it's going to have that factor as well, which is 2x subtract 5, x subtract 1. Okay, our next line would be to combine the tops. So this, we know it expands as following as that, because we've just factorized from that. So that would give 2x squared subtract 7x add 5. I'm going to add this here, expanded, so add 4x squared and then subtract 4x and then take away 15, and all of that is going to be divided by the factors we've chosen as our common factors, which are 2x subtract 5 and x subtract 1. Now it's a bit of tidying up with algebra, simple as that from this point here, and we should get our answer. So we've got ourselves 2x squared add 4x squared, which is going to be 6x squared. We've also got ourselves negative 7x, take away another 4x, which would be negative 11x. And we've got ourselves 5, take away 15, which is negative 10. So negative 10, all divided by 2x, take away 5, and x subtract 1. Now, supposedly it factorizes as follows. So it looks to me that because we keep the x take away 1, this is the type of way you can think in the exam, because we keep that, the top must have a factor of 2x subtract 5 in it. Now, you could get your calculator out, again, go to equation mode, and you could say that the quadratic is 6 for A, negative 11 for B, and negative 10 for C, and you get the answer 5 over 2 and negative 2/3. So if you get the answer x equals 5 over 2 and x equals negative 2/3, you know that timesing by 2 and subtracting 5, 2x take away 5 is 0, it must be a factor, and 3x add 2 is 0. 3x add 2 must be the other factor. So the top factorizes to 2x subtract 5 and 3x add 2. Clearly you should be able to get that yourself anyway without the calculator, but there's no harm in the exam. If you're under pressure, sometimes you make mistakes. Don't lose a mark or a grade just because you couldn't be bothered to check it on the calculator. That can help you. So here we can divide top and bottom by x subtract 5, and we're left with 3x add 2 over x subtract 1. Clearly as well, you knew that the other factor had to be 3x subtract 2 because it was in your question, so that was the other way of checking. You could have just factorized it like that and then known it would have been that, and obviously expanded it to check you got the right expression up here, but there was lots of ways to get there. So that's f of x. We're asked now to, in the next part, we're asked to find an expression for the inverse function of x and state its domain. So obviously we're not going to deal with that complicated f of x anymore. We're going to deal with the new f of x, the nice version, which is equal to this here. Now, the little trick to be able to calculate your f of x's quickly is to call the function y instead. And then what you could do is you can swap the x and y's. The reason you swap the x and y's is because you're now trying to find x as a function of y. So you could swap the x and y's so that you have x here and you have 3y add 2 over y subtract 1. And then your aim of the game is to try and make y the subject of the formula now. So multiply top and bottom by y subtract 1. You'll have x, y subtract 1 is equal to 3y add 2. Expand the brackets. xy take away x is 3y add 2. Bring all the y's together, so xy take away 3y. I'm taking off 3y from both sides and adding x would be x add 2. So I've taken off 3y from both sides and I've added an x onto both sides to get all the y's together, all the x's together. Factorise the y as follows and divide by the x subtract 3. So y is x add 2 over x subtract 3, and that turns out to be your inverse function. And state it at the end. F to the minus 1 of x is going to equal x add 2 divided by x subtract 3. Okay, so make sure you state it back in terms of that at the end, otherwise you won't get the marks for that. So lastly, what we need to do is we need to state the domain, it says. So yes, it says state the domain here. You should know, this is a rule you should know, these bits tend to be tricky. You should know that the domain of the inverse function is the same thing as the range of the original function. So could we find the range of the original function? Our original f of x in its simplified form turned out to be 3x add 2 over x subtract 1, and we were told we were allowed to put in x as any number in the world into that. Now could we find a way of finding the range of that function? Well, yes we could. What we could do is we could have done the following. We've written that in a neater form. We could have performed a little division, so 3x add 2, we could have divided it by x subtract 1. And what would we need up here? We'd need a 3, so that 3 multiplied by this would give me 3x, take away 3, subtract them and you'd get 5. So you could have written this actually as this divided by this was 3 and the remainder was plus 5 over x subtract 1. Okay, so clearly what you can see from this is given that you were told that x could be a real number and x had to be less than 1, x had to be less than 1, so for example x had to be, for example, 0.5 or x had to be -2 and stuff like that. If you put those numbers in here, this whole thing here will always be negative. Okay, so it's 3 combining with a negative number, so this would always be less than 3. So f of x would always be less than 3. So the range is less than 3 of the original function. Therefore, the domain of f dashed x, f to the minus 1 of x, must be that x is less than 3. And you could also look at your original function and see that clearly x can't be 3 because otherwise the denominator would be 0. So this kind of fits in with how the function looks. Okay, going up here, solve the equation f of x is equal to 2. So the original equation f of x is 2. That's very, very straightforward. So all we're going to solve is we're going to solve 3x add 2 over x take away 1 is equal to 2. Multiplied by x subtract 1. 3x add 2 is going to equal to 2x subtract 2. Take away 2x off both sides, and we're going to take away 2 off both sides as well. So x is clearly going to be equal to 4, and we're done.